Right. So our next topic is resonance structures. This is a very important topic in chemistry and specifically with our Lewis structures. And so the kind of short story here is that our letters, right, our O, our S, our dots, our lone pairs, and our lines, bonds, they aren't good enough to accurately describe some real molecules. Right. So as we've learned, these molecules and these electrons are, governed by very complex physics, quantum mechanics. And so our little Lewis structures just aren't quite accurate enough to describe all of the properties that they have. And so one of the issues that we can resolve with our Lewis structures is through the use of these resonance structures. So let's take a look at an example of that. So we have NO3 minus, right? We drew the Lewis structure of this before, and we drew it as this. Right, so if we take a look at this Lewis structure right here, we've got this double bond here. And then we've got two single bonds. And so if we think about what that means, and what we learned about double and single bonds is that the double bonds are shorter than single bonds and they're stronger than single bonds. And so that's our kind of our hypothesis. And then we do some experiments and we get a different result. Experiments show that all three bonds are the same. They have the same length, they have the same strength. And so our hypothesis or our model isn't quite accurate enough. So we're going to adjust our model to make it more accurate, not 100% accurate, but more accurate, right? We're going to take it step by step and get better and better. So if we think about what the kind of, quote unquote, real molecule of nitrate looks like, it looks something a little bit more like this. Where all of these bonds are a single bond, and then I've drawn these as little kind of dots or like little, kind of semi-bonds. And that's because all of these bonds are somewhere between 1 to 2 bonds, right? They're stronger than a single bond, but they're not quite as strong as a double bond. They're somewhere in between. And if we think about the way we chose to draw our Lewis structure, it kind of makes sense. So let's backtrack a little bit and go back to this Lewis structure before we completed it. Right, we chose to pull our electrons from this top oxygen to make a double bond, but all of the oxygens, they're all, singly bonded oxygen to a nitrogen with, 3 lone pairs. We could have just as easily done it from this oxygen over here or from this oxygen over here. They're all equally good options. And so to demonstrate that they're all equally good options, what we're going to draw is each one of them, and then we call these resonance structures of one another. So for example, one of the resonance structures is with that top oxygen having that double bond. Another structure would be with this bottom right oxygen containing that double bond. And then another one would be with this bottom left oxygen having that double bond. Right, and then we can put our brackets and our negative charge, right? So let's take a look at what all of this means. These arrows right here, these double-sided arrows are resonance arrows. And so what that means is that the structure on the left-hand side are resonance structures of one another. So all 3 of these are resonance structures of one another. And let's take a look at how that helps us more accurately describe the molecule. So what we say is that the real molecule, quote unquote, is a combination of the 3, in this case 3, sometimes only 2, sometimes more, so on and so forth, resonance structures. And oftentimes we call this a resonance hybrid. So what you can think about is we kind of superimpose these three resonance structures to get the real one. So the real one kind of looks like this, where all three of the bonds are the same and they're somewhere between a double and a single bond. However, we don't like this model because then we can't quite tell whether, is that a bond and a half, a bond and a third, a bond and a fourth. So what we do is we just draw all of the possible good resonance structures that we have. And then we say that the real one is a combination of the three. So it's not that, at one point the molecule exists like this, then like that, then like that. No, it's the real one is a combination or a hybrid of the three. So overall, in my opinion, Lewis structures are the most important part. Of Chem 100. And so you really want to practice, right? Use your resources, do those work-alongs, go to the tutors, come to my office hours. I'll post some additional videos or links to some videos and whatnot. Really try to get good at this.